Hello everyone, welcome back to Parts Talk. Thank you for joining me. I appreciate each and every one of you. Now today we're going to be looking at an article from interestingenneering.com, and they say here that they have a startup company that claims to improve ICE engines torque by 30% with a small engine change. Now we're going to be looking at exactly what they're talking about and what contribution they have used, but first let's go into a little bit of history of how the ICE engine works. An ICE engine actually stands for internal combustion engine. Let's get right into it.
Our transportation options are rapidly expanding. Consumers are on the hunt for alternatives to traditional gas-powered vehicles that will leave less of a lasting impact on our environment. Despite the rising availability of electric cars and hybrids, gasoline still rules the road. Any car that runs on gas or diesel uses an internal combustion engine. It's what makes the vehicle move. Internal combustion engines accounted for more than 90% of global car sales in 2019.
And to date, it is said there are over 1.4 billion automobiles running on our roads currently all over the world.
Around since 1858, when John Joseph Etienne Lenoir patented the first commercially successful one. By 1876, Nicholas Otto had patented the four-stroke engine, which is the form of internal combustion engine used today. The internal combustion engine has come a long way over the years, and the technology will likely continue to evolve alongside more green alternatives.
Yeah, electric cars aren't taking over, and to think that in the early 1900s was when the first car actually rolled off our production line.
Despite its prevalence, many car owners still don't know exactly what happens under the hood. To work, the engine converts chemical energy into kinetic energy. It does so through a four-stroke combustion cycle, which includes the intake stroke, the compression stroke, combustion stroke, and the exhaust stroke. Intake. The first stage of the cycle begins with the piston at the top of the cylinder. As the engine's crankshaft revolves, the piston moves downward, and the intake valve opens to let in a cylinder full of air and the tiniest bit of gasoline. Compression. The next stage is the compression stroke. Here the piston moves back up, compressing the fuel and air mixture. The piston forms a perfect seal with the cylinder, thus increasing the pressure in the space containing the fuel and the air. Ignition. Once the piston reaches the top of the chamber, the vehicle's spark plug emits a spark to ignite the gasoline, resulting in an explosion, which drives the piston back down. The release of the piston turns the crankshaft, which converts the up and down motion into rotational motion to drive the vehicle's wheels, and the next piston moves up its cylinder. Exhaust. In the final...
Now, all of this is just gibberish to the average guy. He just knows that he buys his car, goes to the gas station, fill it up, engine light comes on, anything else that is wrong with the vehicle, he takes it to a mechanic, back to the dealer, or to a workshop. That's basically what it is.
Stage. Once the piston reaches the bottom of its stroke, the exhaust valve opens, and the exhaust gases leave the cylinder and go out the tailpipe. Then the cycle continues. The whole process happens rapidly, and the temperatures can reach up to 4,500 degrees F inside the cylinder. However, thanks to...
And all of this is taking place under the hood. Everything is connected. Everything works in transmission.
proper cooling, the running temperature of an engine is much lower, around 200 degrees F. So the next time you go for a drive, take a moment to appreciate all the work happening behind the scenes.
And this is something that I've always been saying time and time again. Appreciate the unsung heroes that are there making it happen for you. Meaning that be thankful and grateful for those keeping us safe on the roads on a day-to-day basis. So now that you have a basic understanding of how the internal combustion engine works, let's go into the article and about this company. A small design change in the engine could improve the performance and efficiency of internal combustion engines, a recently funded company, Transcend Energy Group, has claimed. You're looking at the engine on the screen right here. The group showcased its design change at a recently concluded SEMA show in Las Vegas. When the world is looking at electric vehicles to transform transportation, it might seem silly to try and improve the internal combustion engines. Transcend Energy Group's Chief Product Officer and President John Woodard is convinced that we haven't unlocked the potential of ICE. Now they have created the world's first two-piece connecting rod, saying that a connecting rod attaches the engine's crankshaft to the piston and it is responsible for transforming the energy from the piston into rotational energy that spins the crank. In a conventional engine setup, the piston is a pivot point on the connecting rod. I won't read the entire article, but Woodard and his team have focused their development work on the 5.3 liter and the 6.2 liter LS engine so far due to their high demand in the aftermarket. LS stands for luxury sports and can be found in most Chevy models. He said here when the team tested the Thunder Rod on a 5.3 liter V8 engine, the torque output obtained was similar to that of a stock 6.2 V8 engine, a gain of around 30%. The team also found improvements in the compression ratio for a Thunder Rod equipped 6.2 liter LS engine, which recorded 198 psi, while a stock engine only manages 155 psi. While these numbers are impressive on paper, experts are not sure how they will translate into real-world conditions. Changes made to the connecting rod design also require changes to the piston head and camshaft designs. Until these designs are made and tested, the real effects of the design changes won't be completely known, Road and Track said in its report. Now, Woodard and his team are talking to original equipment manufacturers, OEMs, to get feedback on their design and how the system can be improved. The article now ends by saying, will their ideas be able to save the internal combustion engines from oblivion or remain a small collectible for fans of gas-powered engines in the future? Will be known in the years to come. I will leave all these comments to the experts. And if you go to their website, I will leave the link in the description box below. It says here, as this revolutionary technology gets closer to manufacturing and distribution, the anticipation is growing and the line is piling up at our door. Join our waitlist today to stay in the loop with updates on major project milestones. And when we're ready, you could be one of the first to get your hands on the patented Thunder Rod for yourself. While we are currently in the research and development stage, we hope to be preparing for manufacturing soon and distribution by the end of year 2023. Join the waitlist. Let's hear your comments below. Remember to grab a copy of my ebook, The Parts Manager Guide. Please smash that like button on your way out. It will only take you 1.5 seconds to do so. Until next time.